Hello and welcome back. Today we're gonna learn about the hooks in Script and how you can use the hook to execute some kind of event before the block initialize or after the block finalize. The hooks section gonna be still under the section 4, and if you haven't watched it yet, so please revisit all the various sections about the common runtime modules, also about the subtree story abstractions and common story data type, and adding a custom logic to the runtime, and all the videos are already uploaded. So about the hook are a very interesting part of the palette development. And right here is the diagram of how all the hook event executed. Right here we have the on runtime operate, and then on initialize, inherent, polling, and extrinsic, and then on finalize. Extrinsic is where our these are like the mandatory part of the extrinsics. On and initialize is also defined in the palette and executed on top of executed at the beginning of the block. Also on finalize. About the on runtime operate, these hooks are only executed when the code change is detected. When you upgrade a runtime, you might want on the runtime operate, the palette gonna remove some kind of storage items, and it's possible to do that using this hook. And this hook is actually optional and it doesn't require on finalize. For the on finalize, it's marked as mandatory because when you define the on finalize for the palette, this on initialize is always executed, and it's also similar to the on finalize. Whenever the block finalize, this hook gonna be executed. We also have another hook called on idle. So this on idle actually similar to the on finalize, but it's after all the things happens, and then there are still some weight in the block, so that this hook gonna be executed. About the inherent, so most of the time you don't touch inherent, but for advanced use case of substrate, the custom blockchain is substrate, you might want to touch the inherent. So inherent happen before the extrinsic is executed. So inherent happen here when you polling, and then you get an extrinsic and then execute it later. To define the on initialize logic, the block initialization hook gonna happen to this method on initialize, specify with the block number. So when the block number, so when you switch to a new block and that block is in the state of initializing, then this hook gonna be called for every palette. This call at the very beginning of the block executions. It must return the non-negotiable weight of both itself and whatever hook on initialize wishes to consume. So depend on what kind of logic, what kind of operations you put in the on initialize hook, you want to return that weight, so that it's gonna consume from this method. So it's gonna consume from the user transaction submissions. There's also a note here that the weight returned by this is treated as this mandatory, meaning that it must be executed. If this is not the case, considering using the on idle. So the on idle happen after everything's after the on finalize, right? So if you want to do something before the block happen, before the block initialize, you can also using on idle if you don't want to consume any weight from the method, and try to keep any arbitrary execution deterministic and within minimal time complexity. For example, do not execute any unbounded iterations. We're gonna learn why we shouldn't do this later, as we'll have a diagram for that. On finalize, so the block finalization hook, this is called at the very end of the block execution. So in contrast to the on initialize, so this happen after the block finalize at the very end of the block instead of at the beginning. On finalize doesn't mean that the block is added to the change, doesn't happen with the consensus finality, but it is just the block is finalized in terms of block building, not a consensus. Another important note, the weight for the on finalize is also should be considered to return from the on initialize and shouldn't return from this method, because you can see that this method here just consume the block number and doesn't return any weight. And also similar to the on initialize, this hook also should be used with the consideration related to the time executions, and only use it when necessary, and if you usually need this on finalize method to be executed. On idle, so hook to consume a block idle times, they will run when the block is being finalized. So after the block finalization, they're gonna be a sort of time that there's nothing happen there to prepare for the next block building. So given on dispatchable, I already executed and noted. And the wait for the on finalize, which come next, is also already accounted for the on initialize. This hook consume anything that is left over. So any left over from the on finalize and on initialize, this hook gonna consume that's wait. Each palette on idle. So when you define the on idle hook for any palette, it's chosen to be the first to execute in a round robin fashions. On polling is also an interesting hook. It's actually happen similar to on initialize. So instead of using the on initialize, you can also using on polling. On polling, make sure the block is already built and initialized, and then the inherent already happens. So then it's gonna polling, and then this hook gonna be called to run the logic after the inherent applications. The note here is not guaranteed to execute in a block and should therefore only be used in a no deadline scenario. There are also another important hook called off-chain worker. Let's in terms of the Oracle, so off-chain worker basically another service run along with the node. But it doesn't relate to the runtime. So if you have any heavy task that you want to execute, instead of put it in the on initialize or on finalize, you can put it in the off-chain worker. This off-chain worker is not an off-chain service, off-chain server that outside of the blockchain, but it's actually running along with the node, with your substrate node, but it's not related to any consensus or any runtime, but it's just run along with the node. So implementing this function on the palette allow you to perform long-running tasks that are dispatched as a separate thread and entirely independent of the main blockchain execution. So let's imagine our blockchain runtime as as a main thread in the computer, and then you want to spawn a subthread, a dry thread, to execute some tasks. That one can be an off-chain worker. This function can freely read from the state, but any change is made to the state is meaningless. Write can be pushed back to the chain by submitting extrinsic from the off-chain worker to the transaction pool. So the off-chain worker can write to the runtime storage by submitting the transaction similar to the user. Moreover, the code in this function has access to the wider range of host functions in SPIO. That means in the off-chain worker, you can also directly write to this data storage using SPIO. Here you have SPIO off-chain, so the set of API that designed specifically for the off-chain worker. SPIO off-chain also have the HTTP call. That means you can also do kind of things like the Oracle, that you carry the data from the external world, and then using the off-chain worker just submitting that data back to the runtime logic, the runtime palette, and the palette gonna consume the price from the external world. And in the weight and benchmarking sections, I also have this visualization right here. The time executions for the extrinsic for the block on substrate blockchain gonna take around 6 seconds, and there's gonna be 2 seconds available before the main buffer. This 2 seconds gonna be for the block import overhead on initialize, then the extrinsic and the on finalize. So extrinsic is where you define all the dispatchable functions and submit to the change, and it's gonna happen with all these kind of sets like extrinsic base, extrinsic base, extrinsic. These are all the extrinsic that you submitted to the change. And on initialize is gonna happen before the extrinsic, and on finalize is gonna happen after the extrinsic, and all these things gonna happen inside these 2 seconds. The block import overhead is basically when you import the block, you need some time to build the block and then on initialize. I also have an example palette right here that is quite interesting that I wrote when I was in Polkadot Blockchain Academy. This one is direct delegated proof of stake. So basically a direct delegated proof of stake palette allow any user, any account to delegate their token to one validator, so that validator can participate to the protocol and then validate the transactions. And that is the idea of the palette. We don't want to talk much about this palette, but basically we have here, go to the palette storage, and we have the candidate pool that store all the validator who still in the candidate, and then the delegator can vote on this candidate. When this candidate receive enough reward, they can become a validator. The point of the hook used in this case, that what I want to you guys to see is on every error or on every set of block numbers, we want to distribute the reward back to the validator who helps to validate the block. So in the code base, when I search for like on initialize, this code is used like on initialize, and also like some explanation right here. So like on the initialize, whenever there is a block produced, we retrieve the snapshot of the epoch, and the reward, the validator and delegator will be calculated based on that. So like at the beginning of every block, we want to calculate like how many reward like one validator can receive, and also like the delegator of that validator. Then like this really like we check that we do like every block, but it tell that when an epoch has passed. What we want is like after each epoch, let's say like 20 blocks. After the 20 blocks, we want to distribute the reward, and store it into the snapshot, so that we can allow like the validator to claim it back later. So like here we specify the import index, and then which the epoch durations. So like after the epoch, they're gonna receive it, and we store, and then we also like go to a new epoch and report a new set of validators. That's the idea how it works. More about the reward distributions right here that is used on initialize. So the reward for every block produced won't be distributed automatically, but require the validator and delegator to claim it themselves. There's no deadline for claiming the reward. To distribute the reward, the network captures snapshot of the active validator set with its bond and the delegation of those elected validator at the beginning of each epoch. The reward needs to be claimed by the network stakeholder by calling method like claim reward. Reward is distributed to the candidate automatically when they leave the pool. So this hook is very useful, and it's the core functionality of this whole DPoS palette. And that's also like the end of today's video, and thank you for listening, and see you in the next video.